Now, amperage is also another concern of ours. We need to make sure that we can actually produce enough amperage so that our system or unit will actually begin charging. So if you have something that's 20 milliamps, it's not going to cut it. A minimum of 100 milliamps is going to be required here. Now, don't forget your battery will only draw as much as it can. When we're working at voltages and amperages at this level, nothing can really harm your battery in terms of amperage, but the voltage can damage your device, so we need to be very cautious here, okay? With your voltage regulator, you're protected. Without it, you can charge the device, but you will run risk of frying it. So I would try to avoid running a voltage regulator. It's really not that hard to solder and not hard to figure out at all, because we are giving you the diagram, we are showing you how to do it. So I wouldn't worry too much about that. But again, milliamp hours, important. Anything from 100 to 400 is definitely acceptable. Even higher than that, you can't go wrong. But the thing is, it's cost. You're going to have to watch out on how much you're going to be spending on some of these cells. I know some small electronic device stores are selling a rectangular shaped, encased with 2 wire leads coming out of it, a solar panel, miniature solar panel. Some of them can be really expensive. I saw 2 volt, I believe there were 200 milliamp panels. They were going for about $10 a piece. Mind you, it is a good value. You are getting a lot of power out of these little devices. They're already encasing it for you. You're already getting the wire leads, so you don't have to do that soldering. So if you can get a good deal on that, I would do it. You may want to check on places like Alibaba.com, Kijiji.com. You might want to check eBay. You might want to check Craigslist. There are a few different options that are available to you. Check and see what they have. Now, if you try to get a standard style cell, it may not be functional for you. Usually they run at very low voltages, anywhere from 0.5, but you can get some up to 3 volts. The only problem with those is that they're extremely brittle and fragile, and they are designed to be encased into an actual frame. My particular solar panel here is actually made out of glass. It's been hard pressed. It's actually fairly durable. Mind you, it won't withstand you dropping it or anything like that, so you're going to have to be careful with it. However, I always have the option of running rubber around the edges and then putting a backing on it, which is extremely easy. I can even use cardboard as a backing. So, I mean, the option is yours. Why don't I go through a close-up and show you this entire design from start to finish so you can figure it all out for yourself. Okay, so now let me actually show you a close-up from start to finish, and I'll try to go through it as I'm showing you, and you can see what basically this thing is made out of. It's not a very complicated design at all. It's very straightforward, but you always need to see what you're dealing with here. Give me one second. Okay, so start here with the actual solar cell here. Now I have it wired in. I've actually cold soldered this. I didn't need to actually use a regular solder with a soldering iron. That wasn't required. Basically, I used a 2-piece epoxy that you could buy at any local electronics store. What you do is you mix compound A and B together for about, I'd say about 30 seconds, and then you apply it onto the contact leads and onto the surface that you want to bond. It's a good idea to have something press it in. Cure time can take anywhere from 4 to 10 hours. However, if it's at room temperature, it is 4 hours. If you put a light source on it and raise the temperature up to 65, it will only take 10 minutes. So that's up to you. Now I have my 2 leads coming out into the capacitor. Okay. Now the capacitor itself, it actually has a red marking in it that tells you what's positive. And each lead, the positive and the negative, has 4 spades. Now I've ran the device itself in parallel to this battery. If you ever wish to not use a battery pack, you would just connect the 2 reds together or the 2 blacks together. You can still bypass this battery right now by using a double end spade connector. It's your choice. You might notice that the edge of my panel is broken. That's because this is a freebie. I actually got this from an electronics store that had broken stock. So you may want to call a few to see if they have anything they want to let go of. You might even get a really good discount. I would try to give it a shot. But make sure that it's not too damaged. You want it to be functional. Now here's my voltage regulator. This is actually the back side, the heatsink side. I haven't taped anything up yet, so You have to do all of that after you've actually constructed everything, and I'll show you that at the end of the video. But essentially, use my wiring diagram that I'm going to be posting and figure it out. Basically, all you need to do is solder it all together. It's pretty straightforward, and it's pretty simple to do and pretty simple to use. What I would do when taping is to tape each individual leads and then tape the whole thing up as one sum. So it's really just an inline circuit. Okay, here's my USB extension. You can see that the wires are coming off of that. Here's the opposite end that I cut off. This is the male end. You remove that, it's no good. All I need to do now is take my iPod connector, connect it right in, and it's done. And then obviously, we have our device. And that's it. That's pretty much all there is to it.